Everybody, my name's Robin, the CEO of and founder of Canobi Technologies. So I'm going to just talk to you a little bit about ultra-high density farming. We're going to make some small assumptions. One of them is I'm going to be focused mainly on mid-size farming and ultra-high density and sort of what we've been up to, but also what I think it lightly speaks to in the industry itself. So, give you a little bit of a background. We're still quite a small company. We're based out of Canada. We're doing a lot of business now in Asia, Africa, the Middle East. But essentially, we built a farm management platform. So we're primarily a software company, but we do supply all the hardware that is required. So we handle monitoring, automation, and the business tools. So it's a complete technological platform that a farmer should use or could use to manage their farm. This way they're not working on the integration components. We've already done that for them. Lately, in the last year and a half, we've been focusing on ultra-high density and vertical farming, mostly because of the challenges that are there, but we built Canobi to be completely agnostic in terms of the types of growing systems that you can use. We wanted the farmers to be free to use whatever they wanted to use, and we also built it to be very modular so that we look for gaps. We're not there to displace anything that the farmer is happy with or looks at using. So this way, we built it essentially to integrate with the best of breed, whether it's the farming system or whether it's another type of automation system. We're happy to work with it and whatever is required to do the job. So when it comes to ultra high density, they're immediately, as you become more and more dense, there becomes an equal effort to manage the environment. Smaller environments are more complex. Ultra density is probably the most complex. So you need to rely heavily on automation. I'm going to get into that in a little bit. The other thing is that if we're talking about ultra high density using different growing technologies, the ability to be able to customize a platform. So I'm not just talking about Canobi now, but if anybody's shopping for any ultra high density solution, I think given the position that the industry's in at the moment, you essentially need to look at designing a solution that allows you to swap in and out different growing systems. Let's face it, not every growing system is going to be good for every crop you may need to grow. Plus, that's likely where we're going to see a tremendous amount of innovation. So it's very important to have a platform that is customizable. Resilience is something you don't hear a lot of in farming, but it should be. If you look at the average cost of a room fully grown, the cost of those crops, it's an awful lot of money to lose. You don't hear a lot, or we don't hear a lot generally, of business continuity, disaster recovery, and some of the terms that you'd see in other industries. But having and looking at your single points of failure, as the density goes up, this becomes more and more critical. So we look at duplicates, we look at high availability, we look at multiple systems that are running live together so that if a single piece fails, the other pieces automatically kick in. Cold spares sitting on a shelf in the farming industry may or may not be a good way to go. Sometimes you go there and they don't work. So having something that's active and resilient is a key, and that goes up with the density. Data. We all know how to collect data. We collect data, gobs of data. The trick is to do something with that data. So first of all, if anybody's seen, these really cool graphs that come out of an automation platform, actually that data is great for analysis, but you can't feed that back to an automation platform. That data is full of peaks and valleys and AC flapping and going up and down, turning on and off. You can't actually take that data and put it back through an automation system. You actually have to normalize that data, turn that into something an automation platform will understand. So whilst you've got to collect it, you've got to be able to transform it into something that you can play back. And then you need to be able to iteratively use change management so that you can, first of all, determine whether you've got a good crop. Then secondly, version off any iterative changes you might want to make, and then also be able to roll back if you go wrong. So managing data is another key to increasing density. Push alerts, notifications, this is absolutely critical, but one thing to keep in mind when we come to resilience is the average indoor farm, if an AC fails, is probably picking up a degree every 5 minutes. So if your employee that needs to get on site to deal with that HVAC issue is more than 20 minutes away, that's a problem. So alerts, everybody talks about them, everybody builds them in, but there has to be a combination of alerts, resilience, and some of the other things that we've spoken to, because you have to be able to react. Hopefully, if you built the resilience properly, that wouldn't be a problem. And then, of course, mobile access, especially when we're talking about Asia, Africa, and the Middle East. They do far more with their cell phones than we might see in North America. So this is key to have an interface that is useful when it's small, and useful for the right reasons. When you're in the middle of an emergency, you want to know what you would need to know. Oops, sorry. So let's talk about ultra density. So this is what we're up to. So essentially, this is a system called Grow Pipes out of Sweden. And they just make these pipes. The plant fits in them, and you can stack them. It's an incredibly cool, actually, indoor farming and vertical farming solution. So when I first started working with them, they came to us and they said, we've got this system. We send pipes out to a client. The client tends to install them in different ways to get mixed results. Could you design a turnkey solution? So I took a look at what I knew of the vertical farming situation at the time, especially when we talked typical stuff that was out there a couple of years ago. And you would have a wall of plants, a 2-foot gap, double-sided light, another 2-foot gap, and another wall of plants. So when you did the math in terms of plants per square foot, it wasn't obvious to me the benefits. There are benefits in certain situations, but I thought, well, if we want to go high density, let's solve some of these problems. So in actual fact, what you're looking at is this system is 30 centimeters from here to here, so it's a foot, and those rows are 30 centimeters, the pipe are 30 centimeters apart. So in this system that we designed at 7.5 feet tall because we just wanted to get away from sky frames and things like that. We just wanted to work on the system engineering itself. There's 10 plants per square foot. So the interesting thing is, when you look at this, is 10 plants per square foot. Well, how do you guarantee that the environment in the middle of this thing is the same as the environment on the outside? So there's a lot of engineering challenges around density. What we did is we started a little bit wider. We built our lights directly into the columns, and we started to look at, okay, how do we start bringing this in together? And we learned a lot, made a lot of mistakes. What we realized was, though, which was really interesting, is as you bring these pipes closer together and the plants closer together, you use less light. When you use less light, you're generating less heat. So in actual fact, when you go density might be a function of cost in terms of savings. Because if you're using less light, you're spending less money cooling, and your costs go down. So in actual fact, if you were to take that system and run it against a normal system that would be developed 2 or 3 years ago in the indoor farming space, we're at about 50% of the energy footprint of that farm. And one of the things that we regularly hear about, of course, is the cost of indoor farming. Well, as it turns out, we just designed a farm that was 20,000 plants, and if you were to take the approximate square footage of a field and put PVE cells on that field, you would generate almost twice the energy that it takes to run the farm. So there's a lot of interesting innovation going on when it comes to indoor farming and the energy footprint that it takes to run these farms. But they are dependent on automation. They are dependent on a lot of engineering and a lot of management. But that's actually only part of the issue. So right now, because we're shining light from one column to the next, these lights essentially light all of the plants in the area. So there's lots and lots of light overlap. We tried putting typical horizontal lights. We had nothing but trouble. One of the things that we learned is that when you light from the sides, and only from the sides, your plants don't stretch. So you get really nice internodal spacing. You actually get really dense, really productive plants. If you put lights at the top, they'll stretch and you'll end up with a mess, or at least it's not consistent. Because that's the other thing. Density is nothing without consistency. You need to be able to, crop of a crop, produce the same crop from the bottom in the center to the top on the outside. So you have to remove all of the things that may create some variability. One of the things is airflow. So we designed an airflow system that actually doesn't air condition the room. We don't look at the room envelope at all. We monitor it, of course. But actually what we do through our air system is deliver air directly to the plant. So this allows us to air condition the plant. It allows us to dose the plant. And this goes for any platform that anybody should look at when we talk about high-density vertical farming. But one of the interesting things is we can also throw the system into reverse. So during lights on, we're blowing air to the plant. But just before the lights go out, we're actually able to pull air away from the plant and actually remove a lot of that humidity and get it into the dehumidifiers, which, by the way, is one of the biggest challenges in indoor farming. Is it's great to produce all the humidity, but how do you get it through the dehumidifier and remove it efficiently? So we're actually able to pull the humidity through the plant canopy, get it out of the system into the dehumidifiers and recapture that condensate and then feed that back to the system. So we're actually running at about 20% of the water consumption in this indoor farm. And when you start adding all these bits and pieces, we're talking about something that is becoming more and more efficient all of the time. And we've only just begun. The indoor farming industry is in its infancy. It's going to be really, really incredible to see where all this goes. So essentially, you've got a system where you're air conditioning the plant sites, you're pulling the humidity off, the water just cascades down the inside. It's almost an aeroponic system with these grow pipes. And then the water's pulled out. So there's very little water in the actual system. So one thing that is true, the smaller the volume, the harder it is to manage. Bigger volumes tend to be more stable. So less volume, again, we've got the air quality taken care of, but because you've got less volume in your reses and your water, that again requires a high level automation. We actually monitor the water coming back from the system and the water that is coming back from the dosing system into the system so that we can look for percentages of change. This is one of the things, as you go high density like this, as they were talking about actually in the previous presentation, you start to look for indicators. Nutrient uptake is a huge indicator as to whether or not your system is healthy. Evaporation is a huge indicator as to what's going on. Now, of course, we put sensors all through this system so that we can take a look at that even. By the way, we don't use drippers. I hope nobody in the audience is a manufacturer of drippers, but we just found that going full flow got rid of the whole complication of drippers. Lots of the drippers we played with, at least, we had nothing but issues with them. So we're full flow. Plants that are germinated in full flow and grown in full flow typically don't have a problem with full flow. Plants that you take that are germinated in something else and then moved, you end up with transplant shock, and you're going to retard your growth. So this is what the system looks like. Essentially, this is a very interesting kind of kale. It's called black magic. Somebody told me we couldn't grow bell peppers in a vertical farm. They were wrong. Somebody told me we couldn't grow eggplants, and they were right. But they were wrong in the sense that you can grow South African eggplants because they grow about the size of an apple. So sometimes when you're trying to figure out what you should grow in a high-density farm or vertical farm, it's not so much as the one thing you can't grow, but you may find a species of that plant that actually does work well. And in fact, these things are incredibly tasty. and they grow very well in a vertical farm. And this is all growing in the system that you were just looking at. This, I don't even know what we'll call this. This is an experiment at best. This is a lettuce that we have just let grow. It's now about 2.5 feet in diameter. No commercial value whatsoever, but this is just grown in the system. Partially we wanted to see at what point do we end up with root congestion and a bunch of other things, but it's just fantastic. I think partially because inside here you're ending up with a more almost aeroponic solution or an aeroponic situation. We germinate in directly in the system where you can. Typically you would want to do that offline so you save your plants from growing. But one of the things when you're trying to solve food security issues, don't do it when you create another supply chain issue. So we grow in these water pearls. Montreal company produces them. Fantastic product. They're hydrophoric pellets, don't absorb any water, and don't grow bacteria, don't grow mold, and 20-year lifespan. You take them out, dump the plant, clean it, put them back in, and off you go. So it's very dense. In here we're growing, I'm almost done, we're growing strawberries, we have eggplants, we have all kinds of stuff. And that's really, just as I'll leave you off, that's really where the real challenge is. Grow systems will evolve, but the real challenge is harvest management. When you start to have a room with 20,000 plants or 10,000 plants, it's great on day 1, that's easy. But on day 300, when you're pulling plants off that are diverse crops, all finishing at different times, farms' efficiency is about no plant site empty. So harvest management in terms of where do you put the crops, where are they coming off, the supply chain that is required to keep the nutrients and everything in flow, to keep that farm running and keep every single plant site full, that is the real challenge that's coming, especially when we talk about mid-sized farms, high density, low field to plate, and filling gaps in the industry for high margin products, which of course lends itself well to mid-sized farms. Thank you very much.